Okay, logarithmic functions. So a logarithm with base b is read off log base b of x in this case, and this is the inverse of an exponential function. So b to the x, its inverse is log base b of x. We want to get down the definition of logarithm, which is switching back and forth in between logarithmic form and exponential form. It's in the big red box down here, where if we read this off log base b of x equals y, that's an if and only if statement. Then we can rewrite in exponential form. We can say line up the base. So b was the base, how I read this off, log base b of x. So line up the base. It's going to be raised to an exponent, but this kind of looks like b is raised to the x power. That's not really what this means, but that's what this looks like. When you go to exponential form, it's not going to be the same way. Then whatever's left over is going to go on the other side. We also have these properties of logarithms. We're going to get into these more in another subsequent episode. That's what these are. All right, so let's use this definition of logarithmic function and switch back and forth in between exponential and logarithmic forms. It does go both directions because it's an if and only if statement. So these first ones start in exponential form. We want to rewrite them in logarithmic form. So we have to get a logarithm involved. First thing I'm going to do on this, 2 to the third equals 8. I'm going to identify the base is what has the exponent attached to it. That's going to become the base of our logarithmic function. This first one looks like it's this is 2 to the third power. When I rewrite it in logarithmic form, I don't want it to be 2 and then kind of look like it's raised to the third power. So the 8 is going to go on the inside there. What's left over is the 3 goes on the other side. On the next one, we can start out log, identify the base as 5. This kind of looks, this is 5 to the second power. So this is not going to look like 5 to the second power. So the 25 goes inside there, and the 2 to the other side. One more going this direction. We need a log. The base is 10 this time. Now on the inside here, it's going to get that 1/10,000th. And then the -4 goes on the other side. Now that we've seen a few examples going from exponential to logarithmic form, let's try the opposite. Let's go from logarithmic form to exponential form. So I'm going to start out and identify the base. On log base 3 of 9 equals 2. The base is 3. So that kind of looks like it's 3 raised to the 9th power. I don't want this to be 3 raised to the 9th power, so we're going to put 2 up in the exponent, and 9 goes on the other side. What about log base 10 of 1 million equals 6? Well, in this case, 10's the base. I don't want that to be 10 to the millionth power, so it'll be 10 to the 6th power equals 1 million. And finally, over on the right-hand side, identify the base as 6. Can't be 10 to the square root of 6, so it'll be 6 to the 1/2 power is going to equal what was on the inside, the square root of 6. Hope this helps out. This is an important skill to understand how to switch back and forth between logarithmic and exponential functions.